are all.
Yeah. No,
That's now at the beginning of this video. I love it. All right. Take a deep breath in. We're doing 2.2. This is 10 slides long. It says 11. That says slide 11. I pulled a homework problem to show you. So really, it's 9 slides because the first slide's covered. We are looking at the algebra of functions. So this is where some of you might enjoy it more because we are doing algebra. However, domain, I know a lot of people don't like domain. I think you're starting to get better at it or maybe more comfortable with it. Domain is still in here. This is not the domain of the graph. This is the domain of looking at the function. So you need to recall with domain, there's two functions to watch out for. And what I mean by that is, in terms of the domain, that would be, what can you not do with a fraction? You can't have 0 on the bottom. So you cannot have, I'm going to say, when you have a function that is a fraction, it's actually called rational. But we'll say fraction. If it's a fraction, or if it's an even root. Remember, with fractions, you cannot have 0 in the bottom, and with even roots, you cannot take the square root of a negative number. So those are the two that you have to, stop and think to yourself. There's going to be a domain restriction. It's going to come up, so be ready for it. Okay. Before we get to domain, let's just do the algebra. This is one of my favorite. Oh, that pencil sharpener's crap. Go to the one over there by Jack. By the lamp. That was blocked. Before we do domain, let's go straight to the algebra part. We are looking at, slide that over there. We are looking at the algebra of functions, taking two functions, adding them together, subtracting them, multiplying them, dividing them. It's just that's all it is. That's what we're doing. The only complication comes in when you do add or subtract or multiply or divide. You are now changing the domain. That's where there's issues. For instance, if I was to take that function, don't write this, and I was to say, what's the domain? Well, you should recognize this is where you have to start practicing with your math. Tell yourself, what is it? It's a square, which means it starts with a cube. It's a quadratic, which you have to now think that's the one that opens either up or down, and it keeps going, correct? Are there any restrictions on quadratics? No, because to answer that question, is there a number that I cannot plug in there that would give me an error? There's not. You can plug any number in you want, and you'll get an answer, which means there's no restriction. Okay, same thing here. This is linear, because it's a 1. Does this have a restriction on it? No. But if I take, don't write this, the 2 and divide them, now, we do red, now you have to, what? You have to watch out, because now you have a fraction. That little linear crap is now in the bottom of the fraction, which means now there's a restriction. What number is not allowed to be plugged in here? -1. Because if this was -1, I would end up with what on bottom? 0, which is no go. So that's just kind of a game plan of where we're going here. Okay? Now start writing. Okay, so we now use addition, subtraction, multiplication, and division to combine functions. Read the directions. Consider the following two functions. I'm about to sneeze. Okay, here's why I was saying you want a highlighter. I've seen in the past, I'm trying my best to keep in mind where people make mistakes, like in these sections. And I've seen in the past where when we do this, this should be as simple as adding, subtracting, multiplying, dividing. That's as simple as it should be. And people complicate it, or they mess up because of this right here. Don't circle that. They mess up because of the names of the functions. I think they think it's part of the equation or something. I don't know. But you need to train yourself to recognize that that is just the name of this equation. This equation, too much. This is the actual equation that we're interested in. X plus 2. I know, I'm trying to make it quicker. X plus 2 is what we're actually interested in. And it is going to be used anytime you see f of x. This is the equation that we're interested in. And it's going to be used anytime you see g of x. Recall, you don't have to write this, but recall that f of x is just a fancy y. They're the same. They're one and the same. You might think, well, why do they not just use the letter y? Because this means that it's a function, which means it passes the vertical line test, which is huge. That's why they don't just use y. So this is saying the name of the function is f, and the input variable for you to plug in is x. Okay? So I thought maybe if we color coordinate this, you might be able to see that I'm just taking this block for function f, I'm taking this block for function g, and I'm doing what it asks. So what is it asking? Yeah, consider it. All right, let's do this. Let's find f of x plus g of x. Then let's find all right, so write both. Find f of x plus g of x means take function f, green block, and add it to function g, purple block. That's it. And then you combine like terms, if there are any. So I'm going to do that. So f of x plus g of x. I just like to be thorough. So I write it again. Some people might just come right underneath and start writing it added together. I like to show that this is what I'm doing. F of x is what? What's the formula for f of x? X plus 2. Let me color coordinate that. Okay, and then what is g of x? You see that? Are there any like terms? It's nice to get to sneeze. Are there any like terms? The 2 and the 1. Put it in standard form. Pull the x squared to the front, x goes in the middle, and 2 plus 1 is 3, and that's the answer. Now let's repeat with f minus g. Look at the, let me show you something real quick. Notice the difference in this and this. Notice the difference in how they're written. This is where the functions are written like separately, and it's just saying, hey, add them together. This over here is saying take function f, subtract g, leave it in terms of x, which is the same thing as this. Let me change to the pen. So this f minus g of x is the same thing, I'll do an equal sign, as f of x minus g of x. It's the same thing. Okay? There's two ways to write it. So if I throw it at you in this manner, don't think that I've just changed it up. All you're doing is subtracting function f minus g. If I throw it to you in this manner, it's the same thing. It's function f minus function g. The of x part just means your final answer better still have an x in it. That's what the whole parentheses x means. What do we need to remember about subtracting? Distribute the negative to whatever comes after the subtraction sign. You also need to remember order matters. So if I say find f minus g and you find g minus f, those are two totally different answers. So be careful. Now, addition, order doesn't matter, but subtraction, order matters. So make sure when you plug it in, you're doing it in the order it says. Function f is x plus 2. You can put parentheses around it if you want, because what you're fixing to write comes after a subtraction sign. Minus, then we're going to put parentheses, function g. Now you might think, well, why didn't you use subtract parentheses in the addition? Because it didn't matter. You could have put addition, parentheses here. It doesn't matter. With subtraction, it matters because why? Right here. Yep. This little negative right there is an understood -1 that's going to change the sign of everything after it. Okay. So bring this down. This is x plus 2 minus x squared minus 1. Of course, now pulling your leading term to the front, that would be the negative x squared plus x plus 1 is the answer. Go to the next slide. The box at the top is just letting you know the ways that it can be presented. You already saw addition and subtraction. So if I say add 'em, it just means add 'em. If I say subtract 'em, it means subtract 'em. If they are written like this, F, then G, they are side by side, that means multiply. So you might want to make a note here that this is multiply. If it's written F/G, it means divide. Now, huh? No, the new part's going to be finding the domain once you find the sum, difference, product, quotient. Okay, so here we are. Here's where your highlighter is helpful. You've got all this directions. Make sure you know how to read the directions and you know what it's asking. Given that function f of x is this crap, and g of x is this crap, find each of the following. Number, or A says to find what? F plus G. Notice it says of x, right? This means, right here, this means your final answer should have x in it. Okay, so we're just going to add them. So F is x plus 1 I just wrote this down underneath because there's not a lot of room. Plus, what's G? Okay. Here's what a lot of people are not comfortable with. That's it. Why is that it? You can't do anything. This x is outside of the radical. This one's underneath. 1 is outside of the radical. The 3 is underneath. There's no like terms. It's always good to keep your radical at the end. There's no shifting. That's it. It's done. Okay? Let's just kind of practice as where we're going. Can I plug any given number into this and be okay? No, there's a restriction. Can't have a negative underneath that radical. Does any of this first part matter? Not at all. What matters is the x plus 3 would have to stay positive or at the number 0. All right, now, look at B. Let's go back. Look at A, look at B. What do you notice? It's not of x. It's not of x, it's of 6. Okay, so let's go back to A. Let's make a note. This was just finding the sum, right? And I said x should be in your answer. This is find the sum, then what? Plug in 6. Well, when you're doing, we're going to write, you need to be able to write the sum, because in my math lab, it's going to have you write the sum expression, then it's going to say, now find f, like f plus g of 6. So you need to be able to do both. Now, the nice thing is, all right, so I'm going to find it. Well, what did we already find over here? We already found the sum. So I'm just going to copy it to right here. It's the same thing, right? But now I need to plug in what? 6. So everywhere there is an x, I'm going to plug in 6. And the nice thing is, at this point, you could type that in your calculator and you get your answer. Or you could say, I don't know how to do these numbers. 6 plus 1 is 7. 6 plus 3 is, what's the square root of 9? 3. So this is 10. Notice your answer does not have x. That's because it wasn't of x, it was of 6. Over here, your answer had x because it was of x. So I don't know if you want to make a note that when it's of x, your answer should have x. Okay? C is the exact same thing. Find the sum and plug in -4. Okay, well, we already know the sum is x plus 1 plus square root x plus 3. So everywhere there's an x, we're now plugging in -4. Now, if you go to your calculator and type that one in, you're going to get an error. Why? There's a negative under the radical. We are at the point where we would simply recognize that this is an issue. Let me go ahead and write that it would be square root of -1. And we're going to say that this is not real. It's now crossing over into imaginary numbers, and we are not discussing imaginary numbers right now. It is not real. And that's because -4 got plugged in, and -4 is outside of the restricted values. All right, to the next slide. This is to help you understand a visual behind the two functions we just looked at. The function f from the last slide was x plus 1. And the function g was the square root of x plus 3. Okay, so function f is what type of function? It's x to the first power. It's linear. Are there restrictions on linear? No. You can plug anything you want in. You pick any number you want, plug it in, you'll get an answer. That means you're good to go. G is an even root. It's square root, which means watch out. Think of a GPS in my annoying voice. Watch out. Object on road ahead. You're going to have an issue here. This is an even root. You cannot take the square root of a negative number, which means zeros allowed or positive numbers are allowed. Okay? Look at these number lines right here. The domain of f, which was linear, is all real numbers. Makes sense. You can plug anything you want in. The domain of g has a restriction. If you recall from chapter R, we learned that to find the restriction, you take the radicand, you set it greater than or equal to 0 and solve, and that's your domain. So we're going to make note. G of x is restricted. All right, so what is g of x? It was the square root of x plus 3. Which means that the radicand, this is where your thought process should go every time. The radicand cannot be, I'm going to write, cannot equal a negative number. If it cannot be negative, that means it can be the number 0 or it can be positive. So you take the radicand and you set it greater than or equal to 0. This is what you do every time to find the restriction. You're saying, hey, that crap under the radical has to stay 0 or positive. Solve it. So this is the domain. X has to stay greater than or equal to negative 3, which is exactly why you have this number line right here shaded at negative 3 and then to the right. To get the domain of, if I was to add these two functions together, then I have to take the most restricted functions domain, and that's my domain of the sum, or even the difference of them. So if you look at it, this is the domain of f, this is the domain of g. So then what would the domain of f plus g be? It's going to have to take into account that restricted one right there. So that sets the tone. So it's, notice it's the same domain as what just g was. You see that? Because basically it's saying, hey, anything can be plugged into f. You're great. Only numbers negative 3 or higher can be plugged into g. Okay, so now if I take f and g and I add them together, doesn't matter. You still have this square root. So only numbers greater than or equal to negative 3 can still be plugged in there. Because now there's a square root in f plus g. Does that make sense? You will notice if we subtract them, you have to think about it. Read right here. The domain of f minus g and f times g would still be the negative 3 to infinity. And that's because, wrap your mind around this, if I'm just adding them, is there still a square root there? Is that square root still there? Yeah. If I'm subtracting them, is that square root still there? Yes. If I'm multiplying them, although it's ugly, would the square root still be in there? Yes. Okay, so that's why the domain of the difference, the product, and the sum are all the same. Now, notice what's different when you do what? When you divide them, right? Let's make a note. What about f divided by g? What about f divided by g? Well, write f divided by g. F is x plus 1, and g is square root of x plus 3. Isn't that f divided by g? I just shoved them in a fraction. F on top, g on bottom. We have two issues here in the bottom of the fraction. What is it? Can't have 0. This is like a bullet. Can't have 0. I'm going to put denom. And can't be negative. Can't have 0, can't be negative. What is it that we only said over here? Can't be what? Over here we said it just can't be negative. Okay, now we're saying can't be negative. That means it's the same stuff. But now we're saying it also can't be 0 because of the location of it. It's in the bottom of the fraction. So the only thing I have to tweak here is to take away what? Well, what if it cannot be 0? What can I tweak the line, the or equal to, right? This is saying it has to stay greater than or equal to 0. Now we're saying, hey, it can't be 0. So it just has to stay greater than. So if it was f over g, then the domain would just be x is greater than negative 3. Okay, we are going to, well, those are the exact same thing. Oh, because it took up so much room. That's fine.
Wait, how did you put that in there?
Because now, if I said to take f and divide it by g, you'd have this, which means you can't have 0 in the bottom of the fraction, but you also cannot have a negative under that square root. So because it's the same expression, we already said you can't have negative over here. We just tweak it by taking the or equal to 0 off. Because now we're saying you can plug any number in there as long as it's greater than negative 3. If you're not sure about your domain answer, pick a number, plug it in. If you get an error, then you know it's out of the domain. Okay, so like for instance, let's pick negative 4. Because negative 4 is not greater than 0. If I plug negative 4 in here, on top I would get what? Negative 3, which is okay. On bottom I would get negative 4 plus 3 is negative 1. Can you take the square root of negative 1? No, you cannot, which means there's a problem, which it makes sense because we said you have to stay higher than negative 3. So when in doubt, pick a number, plug it in, and see, does it fit the domain that you've just stated? Let's practice this. This is the hardest part. This is 2 slides. And that's only, notice nothing changes. I'm going back and forth between these 2 slides. Nothing's changing because they take up that much room. Okay? So let's look at it first. On this slide, we can find A, B, and C. So find A, B and C, I'm sorry, A, B, and C. Let's color coordinate with our highlighters. We have function f, what is it? And then we have function g, which is x plus 2. All right, let's talk about it. X squared minus 4 is a quadratic. X plus 2 is linear. This is one of the easier problems because are there any restrictions on quadratics or lines? No. There's none. Right? So, from the very beginning, our individual functions, the domains would be what? Individually. Negative infinity to positive infinity. Or you can think of it as all real numbers, right? So I'm going to come underneath it and I'm going to write that individually, the domain for both of those is any given number. Negative infinity to positive infinity. Which means as we are tweaking these, if I find the sum, should anything change about the domain? If I find the difference, should anything change? No. If I multiply them, should anything change? No, because you're multiplying the linear with a quadratic, you're going to develop a cubic. Cubic functions are free range. The only one you're going to have to be careful with is y. It's creating a fraction, right? When I say find f divide g, that means I'm telling you build a fraction, which means watch out, object on road ahead. You cannot have what at the bottom of a fraction? You can't have 0. So that's the only time you're going to have to stop, pump the brakes, and think about it. Let's look at it. The domain of f plus g, f minus g, f times g, and f divide g is what they want us to find. There's a lot of writing here. This is going to be, I'm going to show you how it looks in my math lab. If you add a quadratic to a linear, right? Let's organize this like this. Leave A right here. Come over here and let's find f plus g. It helps to find it before you try to write the domain. Add them together. What's f? X squared minus 4 plus, what's g? Okay, what will combine? Whoops. Right? I combine them. I have no restrictions. And I added them together, and I just have this beautiful quadratic. So do I have any restrictions? No. So what's the domain of f plus g? It'd be negative infinity to positive infinity. So we're just going to come right here and write f plus g, and I'm going to put a colon. We're going to say negative to positive. C says find f minus g. Alright, what's function f is x squared minus 4. Function g is x plus 2. Distribute the negative right here. Watch out, be careful. Then combine like terms. Now you can see why I did this slide repeated. I've already run out of room. So when I subtracted them, I had no restrictions. Subtract, no restrictions, and I ran into A quadratic. Do I have any restrictions? No. What's up, Jason? Yeah. Now I'm going to go to the next slide, and we're just going to continue this problem. So we've taken care of the add and the subtract. I'm going to the next slide so I don't have issues writing. We have F, we have G. We said this is quadratic. This is linear. We've already done F plus G, F minus G, here and here, right? Okay, so we're on D, F times G. F is x squared minus 4, put it in parentheses. G is x plus 2. I'm worried it's going out. I don't remember, let me look in my notebook. I don't remember if they want you to multiply it out or if they'll let you just enter it like that. Let me look. F times G. Okay, I multiplied it out. Let me go to the answer key. They do. They want you to simplify. This is one worked out. They want you to simplify it, so we need to multiply. This is a binomial times a binomial. Two ways to do it. You can do first, outer, inner, last, or you can do this beat repeat method, the distributive property. It's up to you. If you do first, outer, inner, last, first times first, outside times outside, inside times inside, and last items times the last items, and there's no like terms. So I had no restrictions. I multiplied them together. I developed a cubic. Do I have any restrictions? No. So the domain is all real numbers. Now we're going to find F divide G. Let me show you a technique. When you get to this one, I want you to rewrite it like this. And that's so that you maybe will remember there is a fraction here, so I have to be careful. In order to find the domain of F divide G, we need to find the function for it first. We've got to find the function. It means create a fraction, put F in the top and G in the bottom. F goes on top, G goes on bottom. Right? We now have a fraction. What is the problem? Yes, when we actually finish it, we will do that. What's the domain restriction? Can't be -2. Why? X cannot be -2. That is the domain restriction. So that's where you come over here to F over G and you say that x cannot be -2, which means they want it in interval notation. Remember, this means imagine the entire number line is shaded, and you have a big hole on -2. So what would that be in interval notation?
X is greater than
Wait. If the whole number line, like
negative
any number,
so -2
yeah,
versus,
exactly.
Union.
Any number is allowed
Yeah.
except -2. So you've got to put that in interval notation. It would look like this. You probably remember that from chapter R. But it's saying plug any number you want in, but you're going to skip over -2. And that's because if I plug a -2 in right here in this fraction, I'm going to get a 0 on the bottom, and then I have a problem. Now, you do need to simplify. They want you to simplify. So if you were to type that in the computer, it's going to say wrong answer. Clean it up. And that's because, what do you notice on top? It's the difference of squares on top. So we need to factor it. I'm going to come over here. That would be x plus 2 times x minus 2. The bottom is x plus 2. Remember I said you can only cancel factors that are separated by multiplication. Think of it as a giant block. That cancels with that block. That's because there's a, what in the graph? Hole in the graph at -2. So your final answer here for, hey, find the what is it, the quotient would be x minus 2. Which is deceiving. That makes you think, oh, it's a linear function. It's not linear. It's not a plain old linear function. There is a hole. You don't see the hole unless you put them in the fraction form and then stop right there and say to yourself, okay, what's not allowed? If you put them in the fraction form, go straight to canceling, and then end up here, you might think it's all real numbers, but it's not. Okay? And then the last one is g times g. Which looks weird, but it just means take function g and multiply it by function g. Well, that's the standard binomial times the binomial. So first outer inner last that crap, and I have run out of room, so I'm going to combine my like terms all in one step. First would be x squared, outer would be 2x, inner would be 2x, so that's 4x, last would be 4. Are there any fractions or square roots along the way in that one? No. So are there any restrictions? No. So the domain for g times g is all real numbers. I'm going to move on and finish this because there's only one thing left. We will hold off. I'm going to do example 3. We will hold off on 4 and 5 because the ones in the homework, 4's not that bad, or 5's not that bad. We'll hold off on 4 for sure. I'll make that tomorrow at the beginning of class. Look at this right here. This is called the difference quotient. If you go into calculus, this comes in for derivatives, or not derivatives, finding the limit of the graph as it approaches certain values. It's called the difference quotient. You will notice it says f of x plus h minus f of x over just h. Okay? It's called the difference quotient because it is a ratio. It represents the average rate of change, and in calculus, it is helpful to help you when I was saying, in terms of finding the limits of graphs. Go to example 3. That is an H right there. For the function f given by f of x equals 2x minus 3, so there's your block of information. Find and simplify the difference quotient. Guys, this question is just looking to see, can you plug 2x minus 3 into the difference quotient and clean it up nicely? That's all it's asking. So make a note. This is just plug it in and clean it up. You should embrace this question because you will notice what is not asked at all. It doesn't say to find starts with a D, domain, which seems to be everybody's least favorite. It's not asking for the domain. It's Wednesday, Jace. We don't leave yet. It's Wednesday. Yeah. All right. So look at it. Notice this is not just f of x. This is f of x plus h. This means go to your function f of x, and instead of just having an x there, you're going to plug in x plus h. Okay? So I call this my aside. I'm going to find f of x plus h first, because it's going to take a little bit of algebraic work, and I don't want to do it in that giant fraction because then I'm going to get bombarded. This means go to function f, copy it down. What's the function f? 2x minus 3. Okay. Everywhere there is an x, I'm going to plug in what? Everywhere there's an x, I'm going to plug in x plus h. So, because that's multiple things, I need to put parentheses. So 2 minus 3. You see it? 2x minus 3. Plug in what? X plus h. Now, clean it up. Distribute the 2. Minus 3 comes down. Can I do anything else? No. Now, go back. I'm going to draw a line here. That was my little side note. Let me find this crap first. Find first. Let me find this first, because it's going to take a little algebra. Now I'm going to go back and now I'm finding the whole thing. This says, this is a formula, guys. This says f of x plus h goes first in the top of your fraction. You just found it, right? Actually, I'll write the whole thing. F of x plus h minus f of x all over h. Here we go. I just found that. It's 2x plus 2h minus 3, right? What's it say to do next? Write a minus, and then now you do need to put parentheses. Now put just function f. So 2x minus 3. And it's all over what? H. What do we need to do with the negative in front of the parentheses? Distribute right here. So I'm going to come down, I'm going to create another fraction. I'm going to bring this crap down. I'm going to distribute that negative. I'm Want me to copy the h in the bottom? What happens? 2x minus 2x cancels. Negative 3 plus 3 cancels. And I'm left with 2h over h, which, because everything's surrounded by multiplication, what happens there? Cancels, and I'm left with 2. You need to be all but like 1 or 2 problems in 2.2 homework done by tomorrow. Let me show you. There are 2 questions with 14 parts. Listen, Linda. One of them. Hold on. One of them is going to be very easy because every single one of the domains is all real numbers. And then the fraction is where you have to be careful, right? Then it's just find them. The second one is going to have a square root in it. So you have to look at that example and give the square root, all right? If that's the only question you have left, then you're good.